Hello, this is Kenny Belfato at SimTech, and today I'm going to be showing you our Solid Sim software. Working right inside of regular AutoCAD, we're going to draw 3D solids in AutoCAD and do feature recognition. This is a great program for saving time when programming from 3D solids. When you have Solid Sim installed, we add the ability to name parts. You can name your 3D solids right here in the part properties of AutoCAD. Now you can also type in label information, and you can use any of the materials from the AutoCAD material library. Simply installing the Solid Sim, you can put that on multiple computers and they'll all add the ability to name your 3D solids and add label information and materials. It's just a few clicks inside AutoCAD to do 3D solid programming with Solid Sim. Here's our Solid Sim settings. And for example, I could have it ignore anything that's smaller than a 4-inch cube to get rid of hardware like dowels and pins and things. You can filter by thickness, so anything thicker than 2.5 or thinner than 1/8 will be ignored. In the end, it's going to make layered DWG or DXF files, or both. You can configure the layer names. Holes in your model will become circles on layer hole. Dados will become rectangles on layer dado. You can configure the layer names and the colors. Now what you should do is you just pick the button for Solid Sim, select your objects, and it begins the feature recognition process. This is going to make us a cut list and turn each one of these parts into individual drawings or DXF files with geometry on different layers. That's what Solid Sim does. It breaks the solids down into intelligent 2D geometry that you can then cut and nest with Router Sim or any other type of toolpathing program. The feature recognition process completed, and you can make a cut list. Right here, this generates a PDF file. There's our different part names. They use the AutoCAD drawing name if you didn't name them. Here's the part I named side panel. And you can also pick and change the names right here as well. Call that one a rail. And it has the different materials. If you didn't put your own materials, then it separates them all by thickness. The number of parts in here. Quantities, if you've copied parts, are in there as well. 5 of these, 3 of those, 2 of those. So the feature recognition process is complete. And what we can do next is export the assembly. This creates a CSV file. That's our cut list. And it exports each one of these parts as separate drawing files into a folder with the same name as the original assembly. Here's all my parts, today's date and time. There's a rail and the side panel parts. And it also makes the CSV file, which is the cut list, like I said. You've got your name of the part in one column, the material in another column, the quantity in the third column. There's your panel dimensions. We have those as XYZ, so these can be exported to Artist or Cut-Right and make a panel saw program. So here's all your information. Your labels would be here if you had label info. The name of the part without the path is in this column. We keep track of a lot of data inside this cut list, and we really got that with just one click. Well, one more click on that, and you can cut with Router Sim Automation and process and make toolpaths. Before I do that, I wanted to show you some other features of Solid Sim. There's a feature in here called Expand View. And I have them here on the small toolbar. You can go up to the ribbons as well. And when you use the expand, you could either type in a measured value, how much you want to expand the parts, or you could hit enter for drag and use the mouse to move or explode the model out. Moving the mouse slowly will expand the model and contract it. And this has the part numbers on both sides of the part. So this expand is very useful for assembling the parts. You can see the part numbers on both sides. You're in AutoCAD, so you can change the way the view looks using AutoCAD commands. If I just want to pick that part up and move it. Now we can copy this to a PDF file or paste it in a Word doc. The exploded views are very valuable for assembly purposes. There's also a button here that can lay the parts out flat. So when you lay them flat, it shows their orientation, and you can also examine the parts for their feature recognition. So that click right there might take you a long time to do manually. SolidSim does it for you right away. Here's the parts that were ignored. These were modeled as one big solid, so they're too thick for us to do anything with. If they were individual solids, those would have been recognized. If not, they just get ignored. Here are the individual parts. You notice they're all long in X. That's the default. If you don't do anything, we lay the parts long in X, but you have full control over the orientation of the part and which side faces up. There's just some default values. If you don't do anything, the long side is X, and the side that faces up is the side that had the most volume of material removed. There you can see, if I move the part out of the way, the feature recognition. Here's something on layer outside, and it has the depth to cut. That's how thick you drew it in AutoCAD. Here's our cutouts and drill holes on layer hole with the diameter and the depth. There's a little pocket cut, and again, it's got the depth built into it right there. So that's what the feature recognition does. That's the feature that saves you the most amount of time, and it did that for us automatically on all these models. So if I move this model out of the way again, you can see the feature rec that was generated. There's a pocket cut because it didn't go all the way through. These are cutouts. They do go all the way through. There's another cutout all the way through. And there's their feature recognition. Now, we do feature recognition on all 6 sides of the part. And in fact, we even do it more than that. If you had like a stop sign shape, we would recognize holes on any of those planar faces on an irregular shape. So you can see the feature recognition saved us a lot of time by putting all this geometry on separate layers for us. That's the main feature in SolidSim, saves you time instead of having to draw those and put them on different layers. So like I said earlier, you can right click and cut with RouterSim, and we're going to be able to import that cut list and start processing and making toolpaths with RouterSim. So we switch now from SolidSim, which made those layered DXF and DWG files, and we're going to import those and run those in our RouterSim automation suite. It knows the name of the part, how many, and what material, and the layers tell it what type of toolpath to be on. So anything on layer cutout uses a 3/8 tool, for example, at inside cutting at 500 inches a minute. And dados maybe use a 1/4 inch tool number 3 at 350 inches a minute. Outside cutting has a different knowledge, and drilling's a different knowledge. Once these machining knowledges are set up, you wind up using those over and over in all your jobs. So now the automation program has started. It imports the cut list that we just made with SolidSim, and we're going to start making the parts. I have a setting that will automatically make the single part program as well as the nested part program. And that's useful for any kind of remake. If you ever need to remake the parts, you'll have the single part program already generated. We have advanced nesting features in SolidSim and RouterSim. We're going to do things like tool stay down nesting, or we could do common line nesting. We could do 2-sided nesting. We've got advanced small part hold down, so we have 2 levels of small parts, small and extra small. You could specify, for example, that the small parts have tabbing and the extra small uses an onion skin. We can also specify a unique bridge spacing on the parts when they nest. So my small parts can have an extra margin around them. So if I am going to use tabs, there'll be some material left over for those tabs to hold on to. So we've got bridge per part. We've got the advanced nesting features. One of the other advanced nesting features is going to be nest by price or by yield. And if I have a large format machine, I could specify different material sizes. I may have 4 by 8, 5 by 10, 5 by 12, and the software will automatically choose the best yield or the best price based on what you check in the boxes. Another feature we have is advanced cart control nesting. This is for high volume manufacturing. If you want to run 10 jobs together, you'd get a really good yield, but there might be parts for all 10 jobs on one sheet, and we can limit that. We could say I only want to put 3 or 4 carts on the sheet at a time, and then there's a protection there for yield. If the yield falls below a certain percent, then go ahead and add additional parts onto the sheet. These are some of the advanced nesting features we have there. We're also going to be able to do skeleton cutting, where we can use the router to chop up any of the remnants on the table. We have scrap management, a rolling scrap manager to save the scraps. There's a full labeling system built in the router sim. We'll get all these results here in just a few seconds. And I'm going to get all these results really with just 2 clicks. One click to select the solid, and the other one to cut on the cut list. Let's let the parts process and then come back and we'll look at the results. RouterSim just finished making over 50 individual NC program files, and now the nesting process is beginning, and it'll nest on each of the different materials that we had there. If some of the parts are too big for any of the materials, you'll get a warning like we see there, and it'll give us a report, tell us which parts did not nest. So there were several different materials in this job. So we'll see a couple different sheets flash on the screen and nest. There's an example of the multiple stock size. So we've got some smaller sheets here and then a larger sheet. We also got parts inside of parts nesting. So inside this opening of these parts, other parts fit inside there. I'm also using the stay down nesting so the tool stays down and connects from part to part without lifting up. That saves cycle time. You could save up to 20% on your cycle time every day. If you have a lot of parts in your nests, instead of the tool lifting up and rapiding from one part to the next, it'll keep the tool down and connect from one piece to the other without lifting up. That can help when cutting melamines. You won't get a lot of chip out because you're only entering and exiting the material one time. So each of these different materials is processing. It prints these out to whatever printer you have connected. It can also print to a PDF file, so you can get both a hard copy and an electronic copy. We get scrap cutting takes over, so we'll cut 2 pieces of scrap, and it can save these pieces for next time. So we've got automatic scrap management, and then after all the nests are completed, we'll have labels for all the parts. We'll have reporting summaries for all the parts, and all that information is stored inside of a folder with the same name as the original assembly. The process completes. It'll open up the results for us. And in those results, we've got our individual NC code files for each of the nested sheets. I've got my 52 individual G-code files for each single part. Those are useful for remakes. It saved each of the tool paths. It saved each drawing with the tool paths on it. So these are useful as well. If I want to, I can drag and drop these into another drawing file. It saves me labels. Here are the RouterSim labels. Let's get a preview of those. Here's it prints all the labels for all the parts in the job, and we've got a full labeling configuration manager where you could set up these labels, put your own logos on there, add barcodes to every one of them, configure the labels yourself. You've got a full labeling built into RouterSim. We also offer a touch and print program which shows a picture of the nest, and this is what the table will look like at the router, and the operator can come over and pick that part and print it to whatever printer you want. I have mine printing to PDF files. So this is an on-demand labeling. This is one of our products here called Touch and Print, and it's a great solution for on-demand labeling. And the other results in here are simulation files. So with the simulations, you can display a toolpath simulation here. It shows the tool removing material. There's a speed up here you can configure, and it's got play buttons and so forth. So you can see what order things are cutting in. So this was going to do our drilling first. There you could saw the tool stay down nest. So my drilling is a rank number 1. My inside cuts are rank number 2. My outside cuts are rank number 3. You can make a rank 1.5, goes in between the 1 and 2. You can pan and zoom this around while it's playing, so you get a full simulation in there. You get a summary report for the whole job, and the summary report has basically the material information, the yields, and we do that, save that as a PDF, and we also save it as an Excel spreadsheet. And it's got a pivot table, so you can, if you're good with Excel, you can use this data in other places. And it's a great way to do the simulations or the summary reports, because we have very accurate cycle time based on what's called kinematic time study. So you get your cycle time for each sheet and this total cycle time for the entire job. There's each of the different material sizes that were utilized, which tools were used. The material summary gives you all your yield information, what kind of scrap yields and part yields, all in here, to paste a picture of the nests in there. We also keep track of the tools. So even though I cut a lot of tooling at 1200 inches a minute, sometimes I had to do 600 or 450, it slows down automatically. That's the kinematic time study. So you get reports for all the jobs right there. You also get a material usage report, which has all your information about the sizes of the materials and the minimum sizes needed, the total number of sheets to cut those. So in just a few clicks, we took that 3D assembly and we made single part programs and nested programs using Solid Sim to do the feature recognition, Router Sim to make the tool paths, and nesting and advanced nesting to lay those out and put them on sheets for us to give us the best yield. Then we've got touch and print to print labels. We've got Cut Sim, which did the toolpath simulation. And here's a printout of all those sheets saved as PDFs. All of this, right from that right click and cut, it built us the job right here, and I could see each part in a preview window. You can look at the material information. That's basically your sheet size, and they have alternate sizes here as well, so you can pick best price or best yield, stay away from the edges, parts can rotate, make the skeleton cut, make a scrap cut, save the scrap cut, use the scrap cut. These are all the settings inside of Router Sim. Stay down common line nesting, two-sided nesting. Here's your the parts can stay away from the edge by a certain amount. This is a great example here for any kind of time where you want to make the parts stay away from the edge. Here's the example where the small parts are staying away from this 2-inch edge, and they have extra bridge around them. So that way they can have tabs, for example. The large parts are allowed to nest close together and go right up to the edge. That's our Solid Sim, Router Sim, AutoNest, and Advanced Nesting presentation. Please give us a call anytime from our Sim-Tech webpage. You can contact us. This is Kenny Belfato. Thank you so much for taking a look.